You're going to take a look at a few problems that you're going to see on your quiz on Thursday. Yay! Just a reminder, just because the quiz is posted on Thursday does not mean you have to take it on Thursday. We have our meeting on Thursday. We'll be going over some more of the homework problem questions from today's homework and from Monday's homework, so make sure you post those questions on there. And the quiz isn't due till Monday, so please take your time, draw out pictures, do whatever you need to do, okay? You can use all your resources, so like the equation sheet I shared with you guys, use your equation sheet, please. It's going to be a big help to you, all right? So, let's take a look at our problem here. I have a triangle, and I've labeled the sides A, B, C. It looks like we have a distance of 6 meters from point A to point C. And it looks like this happened in 5 seconds. So, let's just imagine my ball is rolling down this ramp of 6 meters. It rolls down in 5 seconds. I want to figure out what is the speed of the ball. Now, this is an equation on your equation sheet, but we haven't really used it for a while. So does anybody know, anybody at all, what equation we want to use to figure out the speed? Anyone? Anyone? Oh yeah, that's right. I'm at my house by myself. Nobody's going to answer. Oh, come on guys, trying to make it fun here. Our equation that we are going to use is our average speed equation. So, that's our average speed equals our distance over time. Now, how is speed different from velocity? Basically, the only difference between speed and velocity, or at least the biggest difference, is that speed does not have a direction. Velocity, as we know, is always going to have a direction because it uses a displacement. And displacement typically has a direction. Our speed does not have a direction. Our speed uses our distance. So, let's figure this out. We are given our distance, and I'm actually going to write this as speed of AC. Why AC? Because I want the speed of the point between point A and point C. That way I don't confuse myself, especially when we get to like frame of reference with calculating speed and velocity. I want to make sure I'm clear what I'm trying to calculate. So my speed of AC is going to be equal to my distance, which I'm given as 6 meters, over my time, which I gave as 5 seconds. Just like with the stoichiometry, guys, as long as we set this up correctly, it's pretty easy. Now all we have to do is calculate. So my speed of AC is going to be 1.2 meters per second. All right, let's try another one like that. Let's just erase this. I want to now find the speed of the ball, but I want to do the speed of AB. So now I want the speed vertical between A and B. In order to do this, we do need one more thing. So I'm going to give us a length here, or a distance. I'm going to say this distance is 3 meters. Okay? So, now we can set this up. If I know that my distance is 3 meters, my time still 5 seconds, then I can say my speed of AB is going to be equal to 0.6 meters per second. All right, let's try one more of these. Okay, so we said that the speed here was 1.2 meters per second. I'm going to write that down. speed here was 0.6 meters per second. Now I want to know, what is the speed of BC? And I am not going to give a distance. So how can I figure out the speed of BC without me giving you a distance? Looks like it might be time to break out the Pythagorean theorem here. I got two sides already. So if I need to just find one other side, I can definitely use the Pythagorean theorem. Speed of BC equal to, I'm going to do 0.6 squared plus b squared, because we're missing that second side, equals, we have our hypotenuse, 1.2 squared. All right. And that's going to, once we do all the math, lead us to 1. I have this set up differently. 0.36 plus b squared equals 1.44. Subtract that, b squared should equal 1.08. Just square root both sides. And our answer is going to be speed of BC is equal to 1.04 meters per second. All right. So that's another way we can find out our speed, by using the Pythagorean theorem. We've done that with velocity. We've done that with displacement. You can basically use the Pythagorean theorem to figure out anything with the triangle, as long as you have the other two sides. All right? Pretty simple. Now there's one more thing we really need to discuss. And that is kind of a new equation, but we've definitely used it before. So I have all this information here. And I'm going to write down, we had the 1.04 meters per second here for our speed. What is now the distance between B and C? I never gave you the distance between B and C. So how can I figure out distance? The easiest way to figure out distance is by putting it all into that speed equation again. Okay, so distance, when we're solving for this, whether you have speed or velocity, you can always put back into this equation. You're just going to be kind of rearranging the equation a bit. So this is new, but not really, because we've definitely done it before. All right. So my speed here between B and C, because that's where we're looking. We're not looking here. We're not looking here. We're not looking at all of it combined. I'm only looking at the distance of BC. So that means I'm only looking at the speed of BC. So the speed is going to be 1.04 meters per second equals, we are looking for the distance over time, 5 seconds. Multiply both sides by 5 to get the d alone, and our answer is distance of BC is equal to 5.2 meters. That sounds like a great answer, but how do I know it's right, Miss Garlie? Well, if you remember from our last video, I believe it was the last one, there's a way that we can double check to make sure this sounds like a good answer. And that is, let's take a look at our triangle again. Remember, the hypotenuse has to be the longest side. So our answer for the distance between BC cannot be longer than 6 meters. Our answer is 5.2 meters, so it looks like it's probably pretty good. All right. Good luck on your homework equations. Make sure to fill out the form. I hope to see you guys Thursday night for our meeting.